Welcome everyone to the last of the series of videos on impulse and momentum. This video is similar to yesterday in that it's 2D conservation of momentum, but this is part 2. Basically, we're going to be doing the same problems, so your problem-solving strategy is the same. Draw a picture, label as much as you can. This helps you to visualize the problem. You will be doing conservation momentum twice, once in the x-axis and once in the y-axis. Again, you will use cosine for the x and y for the sine. Or sine for the y, whichever way you want to do it. Often you end up with two equations and two unknowns. If this is the case, please use substitution. So we'll start right away with a problem. The big difference between these problems and the previous video's problems is that the collisions are no longer at 90 degrees. They are at angles. So it's a little bit more cosine-sine action. That's about it. That's the only difference. We'll stay with the football players running towards each other and tackling each other. Take a minute to probably pause the video and write down the problem, draw a picture, and maybe even give this problem a shot before you watch the video and see me solve it for you. But I think you can do this on your own. So again, I'd stress, give it a shot on your own. The only difference is that it's not at 90 degrees in the beginning, but I'm confident you can do it. I wonder if you pause the video or not. My guess is maybe. But anyway, here we go. I draw the picture of the initial conditions, as you can see here on the right. They stick together, so this is a perfectly inelastic collision. Afterwards, they are moving off at some unknown speed at some unknown angle. Just as before, we start with momentum in the x. You can see this long expression here. The only unknown is the VF cosine theta, so we reduce this down as much as possible, and we are left with VF cosine theta equals 2.39 meters per second. We do the y-axis. Notice that the mass of object A, the 80 kilograms, 4 meters per second, sine 40 is negative. That is because object A is traveling down when it comes to the y-axis. It doesn't matter if it's going to the right. All you care about is that it's moving down, hence negative. Again, the only thing we're left with here that we don't know is VF sine theta. So we have VF sine theta equals negative 0.36, and as you can see above, I isolated VF to get 2.39 meters per second over cosine theta, which we can then substitute in to the y. This was the suggestion in the previous video when solving for angle. Substitute from the x to the y. This way you are left with sine over cosine, which you already know is tangent. And here we are left with inverse tan of a negative number, and that's okay. You'll get a negative angle, negative 8.58 degrees. Please realize that this is a negative y value, so negative 0.36, and a positive x value, 2.39. When you have a negative y and a positive x, we are talking about the fourth quadrant, and when you get to the fourth quadrant, you must add 360 degrees. Hence our answer of 351.42 degrees. You can then take this and substitute it above back into our original expression for VF, and you will solve for VF as 2.42 meters per second. So again, the only difference between this problem and the one you saw in the video yesterday is that the initial conditions aren't 90 degrees. There's just a little bit more angles, so it means a little bit more cosine and sine calculations. Moving on, we will do the football players where they bounce off each other again. My suggestion, read the problem, write it down, draw a picture, and try to solve this on your own before you watch the video and have it solved for you. So if you want to try it, now's a good time to pause the video. For those that did pause it, I hope you got near an answer, and hopefully you got it right. For those that didn't, I don't know why you didn't. I know you can do the problem on your own, but here we go. I start with a picture. In this case, we don't know the initial velocities, so I've just labeled them a question mark. Afterwards, they are no longer together. This is an inelastic collision, but we do know their final velocities and directions. So as before, we start with the x-axis. Writing this very long expression, as you can see here, we get down to a reduced expression where we have two unknowns. Not much we can do there. We have one equation, two unknowns. No big deal. Move on to the y. Here again, please be aware that the mass A, the 80 kilograms, is moving down, and down is negative. Hence the negative times 80 initial velocity of A sine 20. We have this long expression, which also reduces as best we can down to this. One equation with two unknowns. But in the end, we have two equations with two unknowns. As you've done in the past, isolate one and substitute in. We've done this all year. Personally, I'm going to isolate the initial velocity of B because I know I'm going to be substituting that in below, and it's going to be distributed by a positive 30. That's just my preference. You could have solved for the initial velocity of A and substituted that in. So now we have this expression, which requires a little distribution. And once we distribute and combine like terms, we are left with this expression here. And solving for the initial velocity of A, we get 1.58 meters per second. We can then take that and substitute it back into our expression above, and we're left with the initial velocity of B is 0.96 meters per second. In conclusion, just some tips for solving these problems. Again, please watch for directions. Focus, when you're doing the x, focus on right and left, not what's going on up and down. And when you're focusing on the y-axis, focus on up and down, not right and left. And be confident in the method. With these types of problems, you are often going to get two equations, two unknowns, and you'll have to use substitution. This shouldn't intimidate you. You've done problems like this all year. Please trust in the method, follow the method. When solving for angle, just to reiterate this, you often want to isolate the variable in the x and substitute it in the y. This way, you end up with tangent. And be aware of what quadrant that angle is in. This was stated in the previous video. Again, you may want to check out your notes for projectile motion. And we will probably tie these into other concepts, most likely skidding or energy, because that's the most easy. So this concludes our series of videos. I hope you've enjoyed them, and we will continue to work on more problems of 2D conservation of momentum in class tomorrow.